Hi everyone. In this lecture we will discuss the S11 parameter. This is the S11 parameter primarily used to measure the amount of transmitted power. It has also been defined in the previous lecture. At 3 dB, there will be 50% transmission and reflection. Now the question arises, why should the S11 graph be less than -10 dB? And why should it be less than -10, -11, -12, -13, -14 and so on? And why it shouldn't be -8 dB, -7 dB, -6 dB, -5 dB or -3 dB? There are some of the questions that arises. Why should it be -10 dB, or why it should not be -8 dB or -7 dB? In this lecture, I will explain these parameters and why the S11 graph should be less than -10 dB. I will explain these using equations to help us to understand the S11 parameter better. Now, I will explain these parameters as follow. We have studied about the antenna and RF in microwaves, where the transmitted power of an antenna is equal to the input power of that antenna multiplied by reflection coefficient. This equation was covered in our previous classes, so we are already familiar with it. In this equation, the P of T represent the transmitted power, and P with subscript IN, it represents the input power of the antenna, and the tau, it represents the reflection coefficient, which is the power reflected back from the antenna. Now let's look into this example. I have randomly designed or created an antenna. This is just a random drawing. In this drawing, we can see that P of N is the input power and P of T is the transmitted power. And these are the radiation in which direction the antenna is radiating the signal. Here in this case, I considered that the antenna impedance is very well matched with the transmission line or the port of the antenna. Approximately 90% of the power is transmitted. This means that in this case 10% of the power is only reflected and the remaining 90% is transmitted. In such an ideal scenario, the P of T would be 90% of the P of N, which is the input power, because 90% of the power is transmitted out of the total 100, which equates to 0.9 times P of IN. Substituting the value of P of T into this equation yields 0.91 times tau, which is squared. By performing the mathematical calculation, including square root, we arrive at the result. So this was our equation. In this equation, I have put the value of P of T, which is 0.9 of the P of IN. So in this equation, on both hand side, we see the input power, which will be cancelled out. So the remaining equation, if we look into it, on both sides, we see some values like 0.9 is equal to 1 minus reflection coefficient square. So if I need to find the reflection coefficient of this expression, we see that the reflection coefficient is 0.316 or 31%. Moving towards the calculation of S11 parameter, what exactly is the S11 parameter? According to a neatly percentage of the. Now moving towards the calculation of S11 parameter, what exactly is S11 parameter? According to equation, 90% of the power is transmitted. The formula to calculate this parameter is as follow. I have input the value of the reflection coefficient calculated in the last step, which was 0.316, and after performing mathematical calculation of using the formula, we obtained the result that S11 is 10 dB. This indicates that if our antenna is radiating at 90% transmission, then the S11 parameter would be minus 10 dB. This suggests that S11 graph should be less than minus 10 dB. It should not be minus 9, minus 8 or minus 7. However, if the transmitted power is 80%, then the result would be as follow. S11 is minus 7.13 dB. This indicates that even the S11 reflection coefficient decreases, the transmission of the power also decreases, indicating that poor antenna performance. Conversely, if the transmitted power becomes 95% of the input power instead of 90%, then by calculating or applying the above formula, we obtain the S11 parameter as minus 13.1 dB. So, minus 13.1 dB. This suggests that as we move towards minus 11 dB, minus 12 dB, minus 13 dB, minus 15 dB, minus 20 dB, and so on, the efficiency and radiation of our antenna improve. Additionally, if our graph is at, let's suppose, minus 30 dB is the S11 reflection dip, then it suggests that the gain of the antenna is also good because there is a well-matched impedance between the patch and transmission line of the antenna. In this case, I have calculated the equation and the result of S11 against PT being 80%. Similarly, for the case of 90% transmission, I have inputted the value, calculated the parameters, and obtained S11 is minus 7.13 dB. Thus, our transmission is 80%. It shows that S11 is at 7.13 dB, indicating that 90% of the transmission is possible with just 10% reflection. So this was all about our lecture related to S11 parameter. We will discuss further detail of the antenna designing in our next lecture. Thank you so much.